So we are starting Objective 25 today. We're going to use the addition and subtraction formulas to find exact values of expressions. So basically, let me explain what we're going to do today. If I ask you to find the cosine of 30, can anybody tell me, based on your unit circle, what's the cosine of 30? 1/2. Very good, because it's what? Is it square root of 3 over 2? Okay, square root of 3 over 2, because it's your x coordinate, okay? What if I said, find me the sine of 120? What's the sine of 120? Square root of 3 over 2, because it's the y coordinate. Sine is the y coordinate. Okay, so let me explain this. What if I said, find the sine of 75 degrees? Why can't we do that right now? So what we're going to do, though, what could you add to make 75 degrees? What degrees? You could do the sine of 45 plus the sine of 30, and we're going to add that together using an addition formula. You with me? And that's going to give us the sine of 75. Does that make sense? So basically, we're going to be finding sines and cosines and tangents of numbers that are not on the unit circle, but we can kind of mix and match what we do have to get them. Does that make sense? Like we could mix and match the sine of 30 with the sine of 45 to make the sine of 75, right? Yes, no, maybe so? Okay, so that's what we're looking at. So here are our formulas. These are on your colored sheet. I do think that they use symbols. I think what I saw was theta and phi. Again, those are just variables. Here uses S's and T's. You could use A's and B's or X's and Y's or whatever floats your boat, okay? Any questions about that? So I'm going to hit pause for a second and just let you copy these down, and you tell me when you're ready to go, and then we'll try. All right, so we have our unit circles handy. And so we'll use our first example here that I just talked about, okay? I want to find the cosine of 75. Well, the issue right now is that the cosine of 75 degrees is not on our unit circle. But what we can do is we can combine some to make 75 degrees. Combine some that we already have. So you just told me that we could add together the cosine of 45 degrees plus 30 degrees, and that would give us cosine of 75. Yes? So what's our formula if it's an addition? If I'm adding the two numbers together, what's our addition formula? It says we're going to take cosine of 45 times the cosine of 30, the other one. You with me? What comes after that? Minus the sine of 45 times the sine of 30. Okay? So, like when I'm memorizing these, did I do that right? By the way, just for my memory, just making sure I got it. When I memorize these, like notice for cosines, first of all, cosines, it goes together, and then it switches to sine. And if it's addition, then the actual formula is going to use subtraction. Look at the subtraction one. If it's a subtracting, you're subtracting 2 to make 75, then the formula actually uses a addition, a plus sign. Does that make sense? So watch your signs because they do go opposite. Now, I'm pretty sure that I have some people already thinking, like, how did I know to pick 45 plus 30? Could you do it a different way? What else could make, like, could you subtract something to make 75? You could take what? 120 and subtract. Could you subtract 45? So you could do 120, you could do the subtraction version of it and do the 120 angle minus the 45 angle. Does that make sense? So there are going to be multiple ways to do it. What did you say? Could you? You could do 15 and 60, but what's the issue with 15? Because 15 is not on the unit circle, right? So you want to make sure to pick ones that are on here. Okay? Does everybody understand that there's multiple ways to do it? Whatever you have that you can either add together or subtract together to make 75, it will work. Okay? So if half of us did it with the 120 minus the 45 and half of us did it with the 30 plus the 45, it should come out to be the same answer. Okay, so just understand that. All right, so let's just plug in. From here, it should be really easy. So we know cosine is our x coordinate. So use your unit circle. Tell me, what's the cosine of 45 degrees? Square root of 2 over 2 times, what's the cosine of 30 degrees? Square root of 3 over 2 minus, what's the sine of 45 degrees? Square root of 2 over 2 times the sine of 30 degrees is 1/2. So Reagan asked me the question today. She said, is this more tricky or is this more algebraic? I would say at this point in time it becomes algebra. Okay, so let's just multiply. Square root of 2 times square root of 3 is square root of 6. What's 2 times 2? 4 minus square root of 2 times 1? Square root of 2 over 4. And because they have the same denominator, what can I do with them? I can smush them together. Square root of 6 minus square root of 2 all divided by 4. Can you subtract square root of 6 minus square root of 2? Let's go back to algebra for a second. In order to add and subtract radicals, the radicals need to be the same. Meaning, you can only add square roots of 2 with other square roots of 2. You can only subtract square roots of 3 with other square roots of 3. Do you understand? Yeah, they have to match. So here, you can't do anything with that. Okay? You can't factor. Why can't I cancel like some 2's? These are locked underneath. Does that make sense? They are protected underneath. You can't get to them. You can only, in algebra, I always say outside, outside, inside, inside. Like if it's on the outside, you can work with it, but it's on the inside, you can't work with it. Does that make sense? So I would say this is your answer. Okay, so we know, and this is equal to what? The cosine of 75 degrees. Now, if you actually wanted to attach a number to it, what could you do? You could put in your calculator the square root of 6 minus square root of 2, hit enter, get a decimal, and then you could divide the whole thing by 4, and that would give you the exact value. But I really would prefer that versus a decimal. Any questions? All right, let's go to the next one. So I want to find the sine of pi over 12. Okay, is pi over 12 on our unit circle? No. So we need to figure out what we could either add together or subtract together to make pi over 12. Anybody have any thoughts of what you could subtract to make pi over 12? Or add? What do you need to understand? You need to know what pi over 12 is. So I love what Justin did. What did he do with pi over 12? He converted it to degrees. And so I would say if they give it to you in radians today, because pi over 12, you have to find common denominators, and you're going to have to figure out what to subtract. It's going to be easier to be able to mix and match if it's in degrees for today. So I would take this and times it by, what are you going to times pi over 12 by? How do we change it to degrees? What are we going to multiply by? 180 over pi is what you times by. Those cancel, and when you divide 180 divided by 12, you get 15 degrees. So let's use that. So you tell me, what can I mix and match to make 15 degrees? I can take 45 degrees and I can subtract 30 degrees. And that will equal 15 degrees, right? Okay, so let's go to our sine formula. Okay, you tell me, how would I set up my sine formula? What's the first part? Okay, so the sine of s, so this is s minus t, right? Okay, so I'm going to take the sine of 45 times the cosine of 30 minus the sine of, oh, cosine of 45, thank you very much. Cosine of 45 times the sine of 30. Any questions on that? Everybody agree? Double check the formulas because I don't have it in front of me, so I'm trusting you to understand the formulas. We've already used the cosine. Let's go back really quickly and look at our formula. So if I'm using the sine and I'm subtracting, right? It is the sine of the first number, so that would be the sine of 45, right? Times the cosine of the second number. Does that make sense? The cosine of t, which would be the second number, which would be cosine of 30. Minus, then it's the cosine of the first number times the sine of the second number. Does that make sense? Based on the formula? So if we had 45, if this is 45, this would be sine of 45 times cosine of 30 minus cosine of the s, which is 45, times the sine of 30. So I think that's the way we set it up. Okay. All right, so here we go. Go to your unit circles. Let's fill it in. What's the sine of 45 degrees? Square root of 2 over 2 times the cosine of 30 degrees is square root of 3 over 2 minus the cosine of 45 degrees, which is square root of 2 over 2 times the sine of 30 degrees, which is 1/2. So here we go. This becomes square root of 6 over 4 minus square root of 2 over 4, and we can put it all together, square root of 6 minus square root of 2 over 4. And that is a big coinky-dink that it is, a lot of your answers are going to look similar to this today. Can you tell me why? So, like our unit circle is mostly square roots of 3 over 2 and 1/2 and square roots of 2 over 2. You with me? And it will change with signs based on what quadrants you're using and what degrees you're using, but a lot of the answers will begin to look similar. Just know that. Okay? And this is equal to the sine of pi over 12 or sine of 15 degrees, which is pi over 12. Okay? All right. So, you want me to give you a second to maybe try to, I mean, really, it's just figuring out what two angles could either add or subtract to be 165, and then it's just plugging into the formula. Okay, you have your tangent formulas, so let me just give you a second to kind of think about it. Okay. All right, so what are we going to add or subtract? What are our options to get 165? Okay, so I hear all kinds of options. I hear 120 plus 45. I hear 135 plus 30. Yes. I heard 210 minus 45, and I don't know which way you want me to do it. Here we go. Allison gets to pick. 210 minus, I'll do a different one another way. But it should come out to be the same, okay? And it should be the same method, okay? So 210 minus, what did you subtract? 45 degrees. Okay. And I would love it if some of you did some of the other methods. Do your method. Follow along with me, but do your numbers and see if it comes out to be the same. Okay? So, here we go. Our formula says this. Read me the formula. We're going to take the tangent of 210. If this is your S and this is your T, it really, like, especially if you're adding, now subtracting, this has to be S. This has to be T. Do you understand? Because you can't rearrange subtraction. But someone said when they did 120 and 45, they said, does it matter which one's 120 and which one's 45? No, but when you put it in your formula and you say, you know, it's 120 plus 45, then evidently you've made 120S. So make sure you keep it that way. Okay, so the tangent of 210 minus the tangent of 45 divided by tangent of 210 times the tangent of 45. Correct? Okay. I always remember this one because if it's subtraction here, then we start with subtraction, and then on the bottom it flips. That's how I remember that. Okay? All right, so remind me, if x is cosine, y is sine, how do we find tangent? Y divided by x. So you're going to take each y and divide it by the x. So let's look at 210. 210, if I divide the y by the x, I'm going to do negative 1/2 divided by negative square root of 3 over 2. Any questions so far? Okay. You can do your trick, but do you, anybody remember what happens when these denominators are the same? They're going to end up canceling, and you're going to end up, what's a negative over a negative? So this is 1 over square root of 3. What do we need to do with that? Times it by square root of 3. We're going to rationalize it. So this is going to be square root of 3 over 3. Okay. Minus, what's the tangent of 45? What's square root of 2 divided by square root of 2? 1. Everybody agree? Divided by 1 plus, now we just figured this out. What's the tangent of 210? Square root of 3 over 3 times the tangent of 45, which is 1. Okay? Now, knowing our algebra skills, what do you think we should do? There's a lot of different things you could do. Okay, so remember how we talked yesterday? I said if it's separate fractions, you're going to have to simplify each fraction first. But when we have one giant fraction, it comes into play like a complex fraction. Ooh, yuck, gross, disgusty, nasty. You could multiply by, what's 3? You can multiply everything by 3. And is it okay with y'all? I'm going to go ahead and take away this 1 on the bottom, this one right here, because what's square root of 3 over 3 times 1? Square root of 3 over 3. Okay. So I'm going to take the whole thing and I'm going to multiply it by 3. So what happens when I multiply that by 3? It cancels. What do you get? Square root of 3. When I multiply this by 3, what do I get? Negative 3, all divided by, when I multiply this by 3, I get 3. And when I multiply this by 3, I get plus square root of 3. Now, there's an issue. You cannot have a radical where? In the denominator. And if it's a binomial, now up here, it was just one radical. It was a monomial. So we just multiplied by square root of 3, right? But if it's a binomial, we talked about this the other day. What do you got to times by? What's the conjugate of 3 plus the square root of 3? 3 minus the square root of 3. So I'm going to FOIL each of these pieces together. Okay? So, square root of 3 times 3. 3 square root of 3. I'm going to run out of room here. Square root of 3 times negative square root of 3. What's square root of 3 times square root of 3? 3. And it's a negative 3, right? Because it's a positive times a negative. Okay, so minus 3. All right, then negative 3 times 3? Negative 9. Negative 3 times negative square root of 3. Negative times negative is a positive 3 square root of 3. Okay. 3 times 3? 9. What do we know about the outer and the inner? They should cancel. This would be negative square root of 3 square root of 3. This would be positive square root of 3 square root of 3. They should cancel. Okay. Difference of 2 squares. What's square root of 3 times negative square root of 3? Negative 3. Okay, and let's just simplify. Okay, so I can combine this and this. What will that make? 6 square root of 3. And negative 3 and negative 9 makes negative 12, all divided by 6. Okay, and we're almost there. You can simplify. You could take a 6 out from the top. Let me erase so y'all can see how to erase. All right, that's good enough. Let me go up here. And I'm going to flip this around. I'm going to make this negative 12 plus. Generally, you put your real number first, and you put your a plus bi, like imaginaries. You put your radical at the end. So negative 12 plus 6 square root of 3, all divided by 6. All right, so what can factor out from up top? A 6. And when I take a 6 out, what would I be left with? Negative 2 plus square root of 3, all divided by 6. Those cancel, so your answer is negative 2 plus square root of 3. Here's my thought. Did you follow with me through the algebra? Like, I kind of flew through conjugates because we've done that before, right? You know, I kind of flew through the FOIL because we've done that before. Yep. Did I miss something? Okay, so check this out. So here's what I would like for you to do. Okay, I want to look at 135 plus 30. Okay, I want to look at 135 plus 30. And even though we just did it this way, I want to give you a second. I want you to work it out the other way so you can practice multiplying by the conjugate and doing all of that, doing what I just did. And that way I can prove to you should get the same answer. Okay, so I'm going to do the tangent of 135 plus 30. Okay, so I'm going to hit pause for a second. I want you to take a minute and go through this. Do what I just did, but do it with different numbers. Got it? Do what I just did, but do it with different numbers. Okay? All right, so we're going to look at now doing it a different way. We're going to look at tangent of 135 divided by, or plus the tangent of 30. Okay? So if I look at 135 and I divide square root of 2 over 2 divided by negative square root of 2 over 2, what are you going to get? Negative 1. Okay? So this should be the tangent of 135 plus the tangent of 30. Everybody agree? Over, remember I said if you're adding to get it, for the tangent formula, you're going to add it first, and then on the bottom it will subtract, and then multiply times the tangent of 30. Okay? So this is going to be negative 1 plus, let's look at the tangent of 30. So if I divide 1/2 divided by square root of 3 over 2. I feel like some people divided the x by the y and got square root of 3. Double check that. If you got square root of 3, I'm not sure that that is correct because I know these is going to cancel and this is going to make 1 over square root of 3. And when I rationalize that, that's going to become what? Square root of 3 over 3. So that might be one place people were going wrong. Okay? Divided by 1 minus -1 times square root of 3 over 3. Okay? Any questions on that so far? So then I'm going to go to, and simplify this a little bit. This is going to become -1 plus square root of 3 over 3. When you times this together, what do you get? Negative square root of 3. But then when you subtract a negative, that's going to become 1 plus square root of 3 over 3. Did I do that correctly? Did I? Yes, no? Before you rationalize, check it out. What do I have right now? I have itty bitty little fractions within a big fraction. So what do I need to do before you rationalize? You need to, you need to fix your complex fraction. You can't like just multiply by a complex fraction by the conjugate. Okay, so I would times everything by 3 to begin with. So this is going to create what? -3 plus square root of 3 divided by 3 plus square root of 3. Okay? Now we're going to multiply by a conjugate. Creating room so I don't lose you. Okay, so once we times this by the conjugate, yep. Just give me a pen. There we go. All right, so -3 plus square root of 3 over 3 plus square root of 3 times 3 minus the square root of 3 on the top and the bottom. Okay, so -3 times 3 is -9. -3 times negative square root of 3, +3 square root of 3. What's 3 times square root of 3? +3 square root of 3. And then what's square root of 3 times negative square root of 3? -3. All divided by, here, 3 times 3? 9. What do we know about the outer and the inner? They cancel. What's square root of 3 times negative square root of 3? -3. I feel like I've already done this part because this is going to create -12. Did we not get -12 last time? Plus 6 square root of 3, all divided by 6. And then if I factor out a 6, this will become -2 plus square root of 3. And that's what we got. So the first way we did it, 210 minus 45. This way we did it, 135 plus 30. Regardless of the way you go, you should get it the same answer. Okay? All right, so we're going to do one last one. Yeah, hold on. Wait. You don't like this? Well, you have to be strong in your algebra skills. Does that make sense? You have to, and those that had algebra last year probably or last semester are probably rolling with this because it's pretty recent. Those that it's been a year or two since you've had algebra, probably it's a little bit more foreign. So, all right, I'm going to get you started on this one. And this one should be easier. I feel like the sine and cosine problems are a little bit easier. I feel like the tangent ones, because they're fractions and you got to multiply by a conjugate pretty much every single time, are going to be a little more complicated, okay? Anybody have a preference of which numbers I use? 240. Why would I not want to use 15? What's wrong with 15? It's not on here. You've got to use numbers that are on your unit circle, okay? Because there's lots of things that add to be 285, but if they're not on you, it's got to be points that are on your unit circle. So I'm going to use, I heard 240 and 45 first, so that's what I'm going to use, okay? So. No, but this is what you use if you can. These are the formulas you use if you can create them from the unit circle. There's other formulas to use if you can't create them. Does that make sense? But these are the formulas to use, and it's minus, right? Yeah. All right. Did I mess up somewhere? Anybody else get what I got? Oh, I did the tangent. Thank you. Just kidding. It's Friday. All right, so I used the tangent instead of, I wasn't thinking clearly. So cosine here is square root of 2 over 2. This is square root of 2 over 2. So this is going to be negative square root of 2 over 4 minus negative square root of 6 over 4. That's a double negative. So negative square root of 2 over 4 plus square root of 6 over 4. So let's try one more time. Negative square root of 2 plus the square root of 6 all divided by 4. How about that? Does that look better? Okay. The signs, which switched. If you have square root of 6 minus square root of 2, that's the same thing as negative square root of 2 plus square root of 6. Because you probably put 45 plus 240. And does that make sense? So everybody understand, depending on what you use or the order in which you use your formula, if you switch this around, this would be square root of 6 minus square root of 2 all divided by 4. That is the same thing as negative square root of 2 plus square root of 6 all divided by 4. It's the same thing. Right here? Yes, but then it's a double negative, so it makes a positive. Okay.